Okay, so I was teaching lab last night about spectroscopy, and students were asking me questions about stars. And one of the questions that came up is, do stars ever run into each other? I love this question because I have a very fun fact as an answer. So, in just a galaxy, it's very unlikely that stars will just run into each other. When two galaxies are colliding, it's more likely, because now we have more stars in a smaller space. But to get a sense of how unlikely it still is, it would be like if we wanted to get two stars to collide, it would be like me in Phoenix holding this cat toy, and then somebody in LA holding a cat toy of a similar size, and we throw the cat toys at each other and try to get them to collide. And that's about how difficult it is for stars to collide when galaxies are colliding. Which tells you that space is freaking huge! So I like that fact. Hi everyone, welcome back to Astronomy Fun Facts from an Astrophysics PhD student. So today's fun fact is more of a vocab lesson, and the word is spaghettification. Yes, this is a real scientific term, and the definition is even more fun than the word. So spaghettification is what happens when you fall into a black hole. So black holes are extremely dense regions of space with a crazy high gravitational pull. And that gravitational pull increases really sharply the closer you get to the black hole. Now what this means is if you are falling feet first into a black hole, the gravitational pull on your feet is going to be like thousands and thousands of times stronger than the gravitational pull on your head. So your feet get pulled down towards the black hole at a faster rate than your head does, and so your body gets stretched out. It's also called the noodle effect. Essentially, what astronomers are saying is that if you fall into a black hole, you get turned into a noodle. Now, I think you would probably, explode before you would actually get turned into a noodle, but it's a very fun word and a real scientific term, so there you go. Hi everyone, and welcome back to Astronomy Fun Facts from an Astrophysics PhD student. So today, we're going to talk about the Big Dipper, which is this pattern of stars in the sky. It looks kind of like a ladle. Right now it's upside down. That's why it's called the Big Dipper. Now, something you may not know is that the Big Dipper is not a constellation. The Big Dipper is what we call an asterism, which is a very recognizable pattern of stars that's either within a constellation or spans multiple constellations. So in the case of the Big Dipper, it is an asterism within the constellation of Ursa Major, which is the Big Bear. So you can see the full constellation here, and the Big Dipper is only like the little butt part of the bear. Some other common asterisms are Orion's Belt, right over here, which is those three stars right in a row in the center of the big constellation of Orion. And the Summer Triangle, which is an asterism that spans three different constellations and is made up of the brightest star in each of those three constellations, which is down there. Hi everyone, welcome back to Astronomy Fun Facts. Today, we're going to talk about Pluto, and more specifically, why Pluto got demoted. So to understand how Pluto is no longer a planet, it's actually useful to think about the asteroid belt. For those of you that don't know, the asteroid belt is a region of our solar system that falls in between the orbits of Mars and Jupiter. It is filled of hundreds of thousands of little rocky bodies, and they orbit around the sun just like the planets do. Now, the first asteroids were discovered in the mid-1800s, and the ones that were first discovered were the largest because they were the biggest, easiest to see. Kind of makes sense. So when astronomers first found these asteroids, they thought, wow, new large rocky bodies in our solar system, new planets. So for the first few decades of their existence, large asteroids like Ceres and Vesta were considered a planet. However, as technologies improved and astronomers began to find more and more objects in the regions of Ceres and Vesta's orbit, they realized that, maybe we can't really call these things planets. Now, all of the other planets in our solar system have strong gravitational control of their region. So everything that is in kind of the ring that the planet circles in is either gone, it's been flung out by the gravitational influence of the planet, or it has been trapped as a moon. But in the asteroid belt, there were hundreds and hundreds of these things that weren't moons, and they were still there, which meant that our asteroids, the big ones like Ceres and Vesta, didn't really have gravitational control. So astronomers decided to demote them. They were no longer planets, they were asteroids. The same exact thing is what happened to Pluto just about 100 years later. So Pluto is out past the orbit of Neptune, and in the mid-1900s, astronomers began to be able to see objects that were way out in the outer reaches of our solar system. And as they discovered more and more of these, it soon became clear that much like the large asteroids, Pluto did not have gravitational control of its region. There were a lot of other things out there. Now, we call this region the Kuiper belt, so it's kind of just another belt of objects like the asteroid belt, but it's out at the edges of our solar system. Because there are so many objects out there that weren't moons of Pluto and that still were there and hadn't been flung away by Pluto's gravitational influence, astronomers decided that it wouldn't really be fair to keep calling Pluto a planet, and it got demoted to dwarf planet. Now, these labels aren't really that important. Astronomers are much more interested in what these bodies are made of, where they came from, how they evolved, what they can tell us about planets and other solar systems, but everyone seems to be really upset about Pluto, so I thought I'd talk about it. If you want to learn more, I highly recommend this book. It's called How I Killed Pluto and Why It Had It Coming. It's by Mike Brown, who's one of the astronomers who discovered some of those objects that led to Pluto's demotion, and it's a great way to learn more about how astronomy works and why Pluto got demoted. Hi everyone, welcome back to Astronomy Fun Facts from an Astrophysics PhD student. Today, we're going to talk about navigation, because you've probably all heard that people used to use the night sky to navigate, but how does that actually work? So it all has to do with how the Earth rotates. So the Earth spins around its axis, which goes from the North and South Pole, once every 24 hours. And so when you look at a long exposure image of the night sky like this one, what you'll see is that the stars appear to move in parts of a circle due to the Earth's rotation. Now, something you might notice about this image is that these circles get smaller and smaller until you get to this point in the middle where there's not any movement at all. And this point is incredibly useful because what this means is that anything that's in that central region is not going to change position over the course of the night. Now, in the northern hemisphere, what's in that point is Polaris, or the North Star. So not only is this due north, Polaris will not change where it is over the course of the night. Now, if you imagine standing at the North Pole and you try to find Polaris, it will be directly overhead, because Polaris is at that point in the center of where the Earth rotates. And so if you're standing on the axis, it's going to be directly overhead. Now, as you start to move south, you're going to notice Polaris change from directly overhead, and it's going to start moving closer and closer to your horizon, until when you're at the equator, Polaris is right on the horizon. You wouldn't be able to see it. As it turns out, where Polaris is in the northern sky is just what latitude you're at. So I'm in Tempe, Arizona, which has a latitude of 33 degrees, so that means for me, Polaris is going to be about 1/3 of the way from the horizon to the point directly overhead. And this is what people use to navigate, because if you can find Polaris, you can figure out what latitude you're at just by figuring out what angle Polaris is at from your horizon. So if you've seen the movie Moana, you might remember there's some scenes where she uses her hand and measures stars like this. And what she's doing is she's figuring out the angle from the horizon to the North Star so she can determine her latitude. This is something that people have been doing for thousands of years.